Welcome to This Explainer. Okay, today we're diving into something that's honestly a bit of a hidden reality in the tech world. We're talking about why so many software projects literally crash and burn before a single line of code is even written, and more importantly, how we fix it. It's all about laying the groundwork, because building software, it's honestly just as much about human psychology as it is about the tech itself.
I mean, look at this quote. I know you think you understand what I said, but what you don't understand is what I said is not what I meant. We've all lived this communication nightmare in one way or another, right? But in software engineering, this nightmare comes with a massive price tag. Just imagine the absolute heartbreak and the financial loss of building this incredibly elegant, flawless system, only to realize it solves the completely wrong problem. It helps no one.
So here's our roadmap for today. We're going to break down requirements engineering, which is basically the ultimate bridge between human needs and technical code. We'll hit the communication nightmare, the translator role, the 4 core phases, gathering and modeling, and finally, validating the blueprint. Let's get right into it.
Part 1. The communication nightmare. Let's look at how we bridge that gap.
The root of the problem is this massive language gap. Over on the left side, you've got your stakeholders. Think business managers, marketing folks, the end users. They know exactly what they want, their business goals, their wish lists, and constraints like, hey, we only have this much money. But the technical side, not really their forte. Then over on the right, you have the developers. These guys are living in technical architecture, design patterns, and code. They know exactly how to build things, but they need crystal clear instructions on what to build. When these two sides try to talk directly without a middleman, assumptions fly, meanings get twisted, and chaos ensues.
Which brings us to Part 2, the translator role. Enter the requirements engineer.
Requirements engineering is this absolutely crucial early phase. It's where we figure out exactly what needs to be built, way before anyone touches a keyboard. The requirements engineer acts as this vital communication gateway. They have to be completely fluent in both of those languages we just talked about. They take the non-technical wishes from the business side and translate them into strict technical constraints for the devs. And it goes both ways. They take technical proposals and turn them back into plain business terms so the stakeholders can actually understand them and sign off.
But wait, before we just dive headfirst into gathering a million tiny details, we have to start with feasibility and inception. Basically, we have to ask, is this project even a good idea? We ask these broad, context-free questions to figure out the scope, like who's actually asking for this? What's the economic benefit? We check technical feasibility. Can we actually build it? Operational feasibility. Will it solve the real business problem? And economic feasibility. Is this going to make money? If we get a yes across the board, then we move forward.
Okay, moving on to Section 3, the 4 core phases of the engineering process.
So what does the engineer actually do? It really boils down to this 4-step procedural roadmap. Step 1 is elicitation, which is just a fancy way of saying getting the information out of people's heads. Step 2 is analysis, reviewing those ideas, checking for consistency, and ironing out any conflicts. Step 3 is specification, getting it all written down technically into a Software Requirements Specification, or SRS. And finally, Step 4 is validation, taking it back to the stakeholders to confirm, hey, did we actually get this right?
Let's zoom in a bit. Section 4, gathering and modeling. Eliciting the details.
Here's the thing. Users almost never know exactly what they need, or, they forget to mention massive, unspoken assumptions. So engineers can't just ask one person and call it a day. They have to use a bunch of different methods. We're talking one-on-one interviews to dig deep, sending out survey questionnaires to get broad data, hosting focus groups to watch different types of users, say teachers versus students, debate over features, and even peer observation, literally sitting in the work environment to see how a system will actually be used day to day.
Let's ground this with a really cool example from the sources, the Safe Home Security System. Picture this. You're in a requirements meeting, and a marketing stakeholder says, I want our users to be able to access their home security system remotely via the internet. Sounds super straightforward, right? Totally reasonable, basic functional wish.
But this is where the analysis phase kicks in and saves the day. A software engineer looks at that request and immediately spots a huge red flag. Marketing wants internet access, sure, but engineering knows that opens up a massive security liability. What if a hacker gets in, turns off the alarm, and robs the house? This right here is your classic requirements conflict. So they negotiate. They agree, okay, we'll keep the internet functionality, but now we absolutely have to add complex encryption and security constraints to keep unauthorized people out.
To make sure everyone is literally on the same page and to clear up any ambiguity, we create models, like this UML use case diagram.
It's a visual map showing exactly how an actor, in this case our stick figure homeowner, interacts with the system. Those ovals represent the different use cases, things like arming the system, disarming it, or triggering an error. Shifting gears and looking at requirements visually like this forces the team to see things from multiple viewpoints, which is exactly how we catch missing pieces before they become expensive mistakes.
But we aren't just drawing pictures. We structure all these interactions into detailed use case templates. We define the primary actor, their goal, and the step-by-step scenario. And honestly, the most important part, it forces us to think about exceptions. If the normal scenario is just typing in a password to arm the alarm, an exception asks, well, what if they type the wrong password? Or what if a window is open right now? Thinking through all those alternate, messy paths is how we guarantee the system is actually safe.
All right, so how does this build into the next phase, specification? Once we've done all that analyzing and modeling, we take those conversational stories and diagrams and turn them into a highly technical document called the Software Requirements Specification, or SRS. At this point, we're leaving plain English behind. We're bringing in data flow diagrams and data dictionaries, stuff the coding team can actually use to build the thing. It also locks down non-functional requirements. Things like exactly how fast the system has to respond, or making sure it runs on different operating systems.
Which brings us to our final core phase, Section 5, Validating the Blueprint.
Okay, pay attention to this one, because it's honestly one of my absolute favorite concepts from this entire explainer. It's a great little mnemonic to remember the difference between verification and validation. Verification asks, am I building the system right? Meaning, did I correctly write down all the technical specs we talked about? But validation asks, am I building the right system? That means taking this document back to the customer and asking, is this actually what you need? Will this solve your business problem? You absolutely need both.
Now for the harsh reality. Even after everyone gives the thumbs up and validation is totally complete, requirements are gonna change. It's just inevitable. A competitor drops a new product or some new tech comes out. That's why we need strict requirements management. We have to track those changing needs, manage version control, and keep something called a traceability matrix. This matrix is basically a master map linking every single requirement to a specific design element or test case. So, if a requirement changes midway through the project, the matrix tells us exactly which parts of the code and which tests need to be updated.
So before you start coding your next big idea, or before you request a new piece of software for your business, ask yourself this critical question. Are you building the right system or just building a system right? The blueprint absolutely has to be solid before the building begins. If you prioritize requirements engineering, bridge that communication gap, and constantly validate your goals, you're going to make sure your elegant code actually serves a real purpose. Thanks so much for joining me on this explainer, and keep learning.